Hey guys, hope you're all doing okay. Today I'm going to tell you everything that you need to know about PCSX2, how to set up the emulator, what do all the options mean. This is going to be a detailed video and I'm going to put timestamps in the description. However, I highly recommend watching the whole video to fully understand the emulator and its functioning. So without further ado, let's get started. PCSX2, as you know, PlayStation 2 emulator, is so far the only competent way to play PS2 titles on other platforms. There are other emulators for PS2, but they were never able to come out of alpha phase of the development process. I've been closely monitoring every single build of this emulator since 2009, and it has come a long way. It's more streamlined and simplified now than ever. A lot of painstaking development has gone in the way to take the emulator where it is now. To give you some context, here are the official minimum requirements for the emulator. Let's call it low end. And here are the recommended requirements. Let's call it mid-end. And anything above that is high-end. PCSX2 has been in development for more than 18 years and it is still not 100% efficient, and only 17 games out of 2,664 are perfect, meaning that they are completely indistinguishable to tell whether you're running on an emulator or the console. Playable means you can get 60 FPS or plus, but it's not 100% distinguishable. It's all because of the architecture. Toshiba Emotion Engine. This had a very weird and different architecture than anything out there. That is the single reason why it's so hard to develop this emulator. I mean, massive kudos to PCSX2 development members, all previous and current. They have worked so hard on this project. My undying gratitude towards them and the communities. Okay, so we need to download the emulator. As a recording of this video, you can download the PCSX2 from their official website. Now there are two versions of this emulator. One is the stable mainstream release, which is 1.6.0, and it's the stable release. It's not updated as often as the nightly builds. The stable release ensures that you get the best performance, but if you want the latest and greatest, you need to download the latest nightly build, which is available at the link given in the description. I recommend the nightly build as they are constantly fixing bugs and irregularities, so just download the latest nightly build. And to do that, we're just gonna have to Google this, automated PCSX2 build. And if you click on the first link, it's going to give us all the list of all the emulator revisions, and we're just going to download the latest one. So just press download, and after that it's downloaded, we're going to have this file. So I already downloaded, I don't need to do it again. So let's close that for now. If you've decided to go with the stable release, then just install the exe file where you desire and it should be good to go. However, we have decided to go with the nightly builds, and it's just a zip file that you can extract whenever you want and wherever you want. Both of these builds come with all the necessary plugins and memory cards, but they don't come with the BIOS. BIOS is the basic input-output system of the console, and for legal purposes, I have to elaborate that the ethical and legal way is to dump your own BIOS from your PlayStation 2 console. There are tons of places online where you can download BIOS if you just Google it, but I don't recommend you do this because it is illegal. Anyways, after you've done acquiring the BIOS, just put them in the BIOS folder. And now let's extract our emulator. So I'm just going to extract it here. And let's launch it. Okay, so I'm gonna keep it the default language. You can select any other language if you want and click next. These are the two plugins that are available to us for now. Just leave them as they are because we're gonna go into detail about them later in the video. And now we need to select the BIOS path. So just select wherever your BIOS is stored. Mine is here, so I'm just going to select this folder, and you can select this one, USA console version, just for the sake of simplicity. Okay, now we're at the UI. We have launched the emulator. Let's first take a look at the UI. First option is boot ISO, which is going to let you boot straight into your chosen PS2 game. Pause and shutdown are basically pretty self-explanatory. Then we have run ELF. ELF is basically the extension of PS2 boot files. For example, most of the softwares and games for PS2 came with the ELF file, which you can boot without the entire game for debugging purposes and stuff like that. Fast boot lets you skip the PS2 startup, where you saw the Sony logo and the animation. It lets you skip all of that. You can create a block dump if you want to dig into some specific files, or if you're having some issues, you can refer to your dump. If you have any specific game related issues, you can use these patches from here. You can use cheats. Enable host file system tries to emulate PS2 like file system, but it's your computer files. Load and save state lets you load and save a state of the game, and backup before save lets you go back if you accidentally save a state instead of loading. Okay, so honestly, PCSX2 has improved so much over the years that you probably don't need these patches or fixes. So if you go into the CD DVD section, we can see that it lets you choose the ISO files to boot, and if you have a DVD drive, which most people don't, but it's an old computer, so I do have a DVD drive, and you can just choose that and you can boot from your disk if you want to. No disk will let you boot into BIOS instead of the game if you want to tinker with stuff. I'll go over in detail about these settings, so it's going to be later in the video. Multi-tap is a PS2 feature which lets you map more controllers than just one. So if you want more than one controller, for example for player 1 or player 2, you can take multi-tap every 60 minutes, and if Africa an hour passes. The window show, debug and show console they're pretty self-explanatory. If you show debug, this is our debugger, and if you're not doing debugging, then there's no point of having this. And show console is this little window right here. You can hide it or you can show, up to you. And capture video, it's gonna capture the video, or you can take a screenshot, up to you. And if you need any kind of specific help, you can go to the help section. Okay, so this window is pretty important because it tells us like a bunch of cool stuff about our machine. For example, it's telling me that I have this operating system, RAM, the processor, and most importantly this. These are called instruction sets, which are like CPU power tools. So I recommend that you leave this enabled because it's going to give you a lot of information. Okay, so let me explain what these are. To put it in layman terms, these are CPU power tools. The instruction sets which can improve CPU's performance drastically, assuming your workload can support these. These are extremely tricky to implement into programs. SSE2 is for really old computers like Pentium 4 or Intel Atom and dual core Pentium D, stuff like that. The newer version SSE3 were developed for Core 2 and i3s and lower end machines, while SSE4, 4.1 and 4.2 and AVX2 are for newer machines, and these are way better than the previous iterations. So far so good. Alright, now let's jump into settings, and to start off we're just gonna start with emulation settings, the meat and tutorials. The meat and potatoes of this tutorial. The developers say that these are the best settings for most games, with extremely few exceptions. If you have a competent PC with a mid-range COD or higher, these will work fine for you. However, if you have a low-end or even a mid-range PC, these can come in handy. The preset is enabled, and first we gotta disable that to get into the settings. And these presets come with some predefined settings. For example, first one is the safest option. It's put to safe to default. It means that very minor optimizations are going to be made. and only a number of hacks are going to be enabled. And if you choose one which is safest, it means that there are no hacks being applied, so it's going to run natively without any hacks. If you have a really high-end PC like a GTX 1080 or something like that, I recommend this option, as this is going to give you the smoothest experience possible. Okay, and then we have 2, which is safe default. The safer option, it's only going to apply like only a couple of hacks and modifications to make sure that we're able to get the best performance with a little bit of tweaks, ensuring that we get the best FPS possible. Then at 3, we have balanced. If your games are running slower, you can use this preset, as it will enable more hacks. It is a really nice option with good stability. It is recommended if you have a relatively lower spec PC. The key to getting the best performance for low-end PCs is to try different settings combination. Then we have 4, which is aggressive, and I mean literally. You're increasing the number of hacks being applied, so you're going to see artifacts in your games, decreased performance, but sometimes increased performance in a few games. Stuttering, FMV, crashing, and absolutely not recommended unless you're debugging or you have a PC from the 90s. Next level is 5, which is extremely aggressive. So this is the second last level of preset that we can apply. This is really going to apply a lot of hacks and a lot of optimizations and tweaks to make sure that we are getting the most amount of FPS possible, but it's also going to break your games entirely. You're going to get like significantly lower FPS, and it's not going to run very well. So this option is absolutely not recommended. It's only for debugging purposes, because developers wanted to see how far they can push this emulator on the lower end of the spectrum. Okay, so then we have 6, which is mostly harmful. I mean, the name says it all. It's mostly harmful. You get all the hacks, all of the tweaks, all the optimizations are going to be turned on, and they're not going to play nice with each other. So, and you're going to get 700 and 800 FPS, but your screen's going to be black, because trust me, I've tried this before in the past, but it's not good at all. Okay, now we have presets out of the way. Let's get into each option. First, we have Emotion Engine and IOP, which is the Toshiba Emotion Engine that I mentioned earlier. The emulator tries to emulate the backbone of PS2 in here. Recompiler is the fastest option, and Interpreter is only for debugging purposes. Do not enable Emotion Engine cache because it does not play well with the rest of the configuration. Then we have Advanced Recompiler options here. These are special operating modes of the compiler with a little bit of extra features. I highly recommend leaving it to Chop 0 and Normal because it has the best implementation. The rest only work in very specific scenarios, and they're not going to improve the performance that much. And then if we go into VUs, then we have Micro VU Recompiler for VU0 and VU1. Leave it as it is. This is the new revision of the compiler. It has way more compatibility than the old one, and not to mention, it is way less prone to errors and emulates accurately. There was another option in here called Super VU Recompiler, which was an experimental recompiler, and it did increase the performance in certain titles. They removed it with the latest revisions because I think it wasn't that practical and it might have caused some issues. In this section, GS, you can disable frame limiter if you want. So it's uncaps FPS is pretty self-explanatory. Okay. MTGS, this one is only for debugging purposes. Here you can adjust the frame rate if you want. Not that useful. Next up is frame skipping. Frame skipping is a technique where a couple of frames are dropped to give you the illusion that the game is faster. It's for the lower end PCs, and you can use it to make your game run faster, sacrificing the smoothness in the process. You can keep it disabled, but when you hit the tab, it will enable frame skip. So if you choose this option. For example, I don't want it enabled all the time, just in some games, so I can just press tab to enable it. Third option is constant skipping. In here you can specify how many frames you want to skip from a certain number of frames. For example, for every 60 frames that I draw, I can skip 5 of them. So it's going to give me a pretty good experience considering my low end hardware. And you can also keep it to 7. This is the sweet spot where the experience is bearable and the game is playable. But if you skip too many frames, then it's not gonna be playable. You're not gonna know what's happening. Next up, in the window, GS window, you can specify the size of the window and aspect ratio. Some game cutscenes have black bars at the top and bottom, so you can just to give it more cinematic feel, then you can just select one of them to make sure that the aspect ratio plays nicely with the FMVs. Okay, you can override this and apply full screen options from this tool. Okay, here we can specify the size of our custom window if you're going to be using your custom window instead of a full screen. VSync is a synchronization tool which prevents your screen from tearing, but it can also take a toll on your performance. I recommend it leaving off or adaptive unless you have a really terrible screen tearing effect. Next up is speed hacks. These ones are the hacks that actually affect your performance in majority of the cases. First up, we have emotional engine cycle rate. If we go to the left, we increase performance by reducing CPU requirements. Low-end PCs select the first level, so just this one, -1. I should warn you, going further will only break your games. For example, if you go here or here, it's only gonna break your games. To the right, you can adjust the cycle, which will increase your CPU requirements, but it's good for games which have uncapped FPS, and you can use more FPS to gain more performance. Only use level 1 if your CPU is high-end, because other levels can crash the game and the emulator. There are very few exceptions which can have a performance gain if you decrease the CPU requirements all the way to the left. You can try this if none of the other configurations seem to work. This toggle is there to decrease the clock speed if you're at the low end, or increase the clock speed if you're at the high end to get more performance and more frame rates respectively. Just like frame skipping, EE cycle skipping can skip some cycles of the process, which can make your game run faster in a very few scenarios. Only use the first level. So normally at default it's at here 0, but you can use this one if you're having some speed up issues. Only these options are going to play nice with the rest of your configurations, because these have very good stability and compatibility. So I recommend leaving these on, because on most of the hardware configurations, these are gonna play nice with the rest of your configuration. So just leave them on. In my experience, this one, MTUV, is a huge speed up if you have multiple cores. Even if you have 2 or more cores, it's worth trying. I've had huge success with this option. These are the Gamefixes, and I recommend keeping them disabled and only using them if you have that specific problem in a specific game. Alright, now that we're done with this, I'm just gonna cancel it, and now let's go to audio settings. So these are pretty self-explanatory. And one tip, you can leave the audio disabled, no sound. And sometimes, like only in a very few scenarios, it can increase your performance. So if you have a really low-end computer, you can leave it off, and you're gonna see a somewhat in performance increase. So I recommend using 0 nearest fastest bad quality if you have a low-end PCs, but select 4 if you have a relatively high-end PC or even a mid-range PC. And here you can adjust the volumes and latency. And the next one is memory card. Here you can specify the path for your card, and there are also some programs you can launch to actually get the dump from your PS2 console memory cards and then convert the files to make sure that all of your save games are available on this emulator as well. Now let's go to plugin and BIOS selector. In the latest build, there are only 2 plugins available. Before there were like 8 plugins. Now most of the stuff is integrated into the emulator itself, so we don't need external plugins for stuff. Now we're gonna cover the second last setting, lily pad, which if we go to configure, it's just the controller mapping you can do. Raw input is a method where whatever you type with your keyboard is the input is going to be sent to the game or the emulator without mapping to anything. Direct input is the old legacy method of taking input, and it is more suitable to the old controllers. In mouse API, you can enable the game to take inputs from the mouse. I recommend using Windows messaging unless you're playing a very specific game with a tricky input system like controllers with the steering wheels and fake guns, etc. Enable logging is gonna log every event, and it will be available in the lilypad log file if you want to track down a specific event or an error, or if you want to get bottom of an issue. In pad 1, you can map to your heart's content in the different things, and you can also adjust the sensitivity settings in here. Last setting I changed the most when I had a low-end PC is the GSDX. We have 2 options. First is AVX2 and SSE4. SSE2 is only for the low-end PCs. Please don't enable that because it's going to give you like really bad performance. So if you have this option, just choose this option because this is the fastest option available. SSE4 is for the relatively new ones where you don't have AVX2 available to you. And the best extension to use is AVX2. This is the best extension and instruction set available to take advantage of the newer architectures, and the best performing as well. If you have this extension available on your machine, please select this from the plugins, and it's the best performing one. You can see it in the console windows which extension and instruction sets that you have available in here. That's why I said that we should have it enabled. Okay. Let's get to configuration, and for some reason I can't go into configuration. So if I go into configuration, let me select AVX2. That's new. I got an error. The CPU does not support AVX2. It's a 3rd generation i5. Okay, so a good example. We're just gonna use SSE4 because the configuration inside the plugin is just pretty much the same. If you have a high-end PC, go with OpenGL as it's relatively more accurate render, but it requires a little bit of oomph. If you have a low to mid-end PC or even a relatively high-end machine, always use Direct 3D 11 because it's faster while also keeping accuracy intact. If you don't have a graphics card, you can use a software-based rendering, but it's gonna be way too slow. But if you have a high-end machine with no graphics card, it's going to give you a playable performance. Sometimes in PCSX2 games, you can see a visible shaking of the output screen itself. So you can use the interlacing feature where you can cope with this issue. Each of these interlacing options can be used depending on which way your screen is shaking. If it's shaking to the right side or the left side or downwards or upwards, you can use one of them. And texture filtering, we're just gonna leave it to bilinear PS2 because this is the best option, or you can leave it to nearest if you have a low-end PCs. Otherwise, I recommend leaving it to bilinear PS2. And the rest of the settings, this one, internal resolution. So the native is only going to render at 480p, but if you have a mid-end PC, just select 2x native. It's not going to take that much of a performance toll, so I recommend leaving it at 2x 720p. But if you have a low end, you can choose it. You can choose native. And this one, allow 8-bit texture. This is going to enable or disable 8-bit texture. If you have a GPU, a good GPU, then leave it enabled. But if you don't have if you have a low-end GPU, then leave it disabled because then CPU is going to handle most of the tasks. Anti-scoring filtering, you can specify what scale do you want it, 2x, 4x, 8x, or 16x. Dithering is if you see a specific artifact in your game, you can leave it to off, but normally just leave it on scale as there are a very few number of games that's gonna affect the performance. MIP mapping automatic default is gonna see if your game and your configuration supports it, so it's automatically gonna set, but you can leave it off if you see like stuttering, sudden stuttering or sudden jump in the FPS. You can leave it off, but I think automatic is okay. These are specific hacks for the games, and we're just gonna leave it to automatic, or you can leave it to none. I recommend leaving it medium if you have a high-end PC, otherwise just leave it to none. And if you want to tinker with some specific shader settings, like brightness, contrast, or saturation, you can use these options, but they're not going to affect your performance. And if you want to mess with shader compilation and red, blue hues, you can use this option. Now, these are important because sometimes you get lines, vertical lines in your games, and these options can help you disable them. Or sometimes you get horizontal lines or some GSDX artifacts, like you're gonna see some bugs or errors or some discrepancies. So if you see any of that, I recommend leaving these three options. But I recommend that you keep them disabled if you don't see, if it's only for that specific scenario. Just click OK, OK, and that's it. Alright guys, that was our basic look into the PCSX2 emulator. And now that we have come at the end of the tutorial, I'm going to give you the recommended settings that I use for low-end machines first. So let's go to Emulation Settings. I'm just going to keep it disabled and keep it in mind for lower spec PCs. Disable frame limiting constant skipping. Actually, I'm just going to select this. Fit to window and screen off, and that's fine, and I'll leave it disabled. Keep it 1 and 1, and I press OK. Now for the video settings. I keep it D3D and use this. I always enable this on the low-end PCs and native PlayStation 2. I disable this unless I see some artifacts in the game. Okay, so that was your settings for low-end PCs. But if you want some high-end settings, then you can choose the following settings. These are going to be the same. Disabled, no frame skipping, GS window, it's going to be the same. And I would recommend you choose this to adaptive. Enable speed hacks. Just leave them to 0, it's not going to do anything, and enable this option. Okay, and if you go into video settings, this is no plugin loaded. Direct 3D11 or OpenGL. OpenGL is a little bit more accurate. So let's leave it to OpenGL automatic bilinear, and then if you have a good GPU, disable that, and you can enable it, any of these options depending on your PC. So what I leave it to 3x native, and I enable large frame buffer. It can prevent flickering, and it doesn't have that much of a toll on your machine. And I don't do any of these settings. Okay, so these were your settings for the high-end and relatively mid-end PCs. So there you have it, guys. This was your complete guide to PCSX2. Hey guys, hope you're all doing okay. Welcome to the complete tutorial for RPCS3. In this video, you're gonna find everything that you need to know about RPCS3. How to set up the emulator, what do all the options mean. This is going to be a detailed video, so I'm gonna put timestamps in the description. But I do recommend watching the whole video. Let's get started. To give you some perspective, these are the minimum specifications, and let's call it low end, and these are the recommended specifications, let's call them mid end. Anything above that is high end as always. I've been closely monitoring RPCS3 build since 2011. I remember when I first downloaded the pre-alpha release, a proof of concept which it was just a teeny tiny window with only one drop down option in the UI. It was just an interpreter debugger. It was only able to run a tiny part of the PS3 firmware code. Very comforting to see that after 15 years of console being out, we can play several titles on the emulator. My and community's undying gratitude towards RPCS3 developer team and Patreons. PS3 architecture is extremely tricky. So many rendering pipelines, modules, and the way they communicate with each other, the PPU, the SPU, and shaders, it's all very sophisticated. It was a relatively hard platform to develop titles on, but also had a lot of untapped potential. Developers slowly got the hang of it, and we were granted games with relatively amazing graphics and smooth FPS. Small problem, however. This kind of design is ridiculously difficult to emulate because a PC consists of CPU, RAM, storage, graphics, along with different data lines and buses in the motherboard. Tricking each part into doing what PS3 does is the main game here. So that's your answer to the question, why does my PC require so much specification when it is 50 times more powerful than a PS3? As the making of this video, more than 1900 titles out of 3100 are playable from start to finish. This goes to show you that team put a lot of effort into making of this emulator. Okay, so as you know, there are two ways to download this emulator, mainstream release and the GitHub revision. So in this instance, we're gonna go with the mainstream release. So you can just go to rpcs3.net. So this is their official website, and just go to the download section to download the latest revision. So here's our version for Windows, and here our version for Linux. We're just gonna download the version for Windows. If you have Linux installed, you can download that, I guess, but the intricacies associated with Linux, oh my god, I don't know how would you solve an issue regarding this emulator. So I hope that you have Windows. I've already downloaded it, so I'm not gonna download it again, but hopefully that was helpful. Now you need to have Visual C++ 2019 installed. I've put a link in the description if you guys want to download the standalone version. Remember to restart your computer after installation. The final thing that you need is the PlayStation 3 firmware itself. Again, link is in the description, but you can also download it at the PlayStation's official website. Last thing, we need RAP files to boot PS3 games. RAP files are used to activate PS3 games. These can tell the console whether a game is pirated, copied, or ripped. Only original games came with their own unique RAP files, which are used to tell console that the game is legit and original. You can Google each game's RAP file and download it, find it on websites like PSNDL by using its name and region like PAL, US, JAP. Otherwise, the games won't boot on the emulator. I don't recommend you do this because the only legal way to play PS3 games on the PS3 emulator is to extract your own from the PS3 disc that you already own or buy some legit disc. Sorry guys, trying to put a disclaimer as I want to be as thorough and clear as possible. Thank you for understanding. Ideally, try to install it in an SSD if you have the option. It will help with the compilation times. If you don't have then an SSD, that's fine too. So let's see here. It's in this directory RPCS3, and this is the PS3 firmware file. I've already downloaded it, and this is our downloaded version for RPCS3. I'm just gonna extract it here. Yep, it's extracted, and now I'm gonna launch it. So it says RPCS3 does not condone piracy. You should dump your own games. So I've read the quick start guide and don't show me again. Continue. So now we're at the main UI. There's something I would like to mention. I was running this emulator on a really crappy laptop. It's a very old machine because I like to see how far I can push the old hardware. I got a Vulkan API error. If you get that too, I have a Vulkan API installer in the description that you can download and fix that error. After everything is set up, it should launch without any hindrances or errors. Okay, so let's get started. In File UI, we have boot self ELF. ELF is the PlayStation 3 boot file extension. PS2 console had the same extension. If you want to boot just the boot file of the game or a PS3 software for debugging purposes, you can boot that file. For example, if you're using Codebreaker or Action Replay or some sort of trainer or cheat system, you can use this option. And boot game is gonna let us boot our game. Now there are two types of games. One is extracted, which is going to be a directory or a folder, and the other one is PKG or package file, which you have to install. And normally our default game directory is dev hdd0. This is our main game directory where our game is going to be stored ideally, but you can also give it a custom path, so it's not a problem. Now, next up we have install package and RAP files. You can install package or associate different types of RAP files with the games that you already have. Then we have install firmware. Now we're going to install our firmware, which we have it right here. So let's install it here. It says old firmware detected, the newest version is 4.87 and you're trying to install 4.86. Continue installation. Actually, I downloaded this a while back, so I'm not gonna bother with the new version, but you can install the new version if you have to. That totally up to you. So I press no and hopefully should start the installation. Okay, I said I think it's a continue installation. I press no, so let's press yes. So you might be asking, what's the difference between the two firmware versions? So they like to revise the firmware because sometimes you can find undiagnosed bugs which were completely unknown before, but they just fixed it. But in the emulator, from an emulator perspective, it doesn't matter that much. But if you want the ultimate performance, you can download the latest revision of the firmware. That's totally up to you. But I already had the previous version, so I didn't really bother. Okay, so let's go through the other options. Then we have all titles, and here we have create PPU caches. So after this is installed, it can now run PS3 games. It's going to compile the PPU module, which are required models that come with the firmware, so it can let us emulate the architecture. So you see this running in the background, so that's what it's doing. And in all titles we have PPU caches. Whenever you run a title, it's going to compile its own SPU, PPU, and shaders. So these are your CPU, GPU, and shaders. This is done to let emulator access the game files. By having these on standby, it can reduce loading times, recall graphic shaders, and link the SPU with our unit. In short, instead of loading shaders, linking PPUs and SPUs every time you boot a title, you can keep these files on your SSD or hard drive to eliminate the compilation times. Depending on the game, the more you play it, the bigger is going to be your shader bank. So from here you can manage all those options. Yeah. So in firmware we have create firmware cache, remove firmware cache, any additional or system files that firmware might create, we can manage it from here. Next up we have emulation, which is pretty self-explanatory. Pause, stop, restart, open command prompts, and exit command prompt, which is gonna let you view the logs or open the command prompt for any reason that you like. So whenever you play the game, the more you play it, the smoother it's gonna feel, relatively smoother. And one of the amazing RPCS3's function is that it lets you create custom configuration files for each of your games. Different controllers, different renderers, different settings, a whole lot more. So depending on the game, because every game is going to support different settings, and you can string a bunch of different settings together to see which ones work for your game the best. And that's how you can get the best performance out of a game. Okay, so except for pads, this one, and RPCN, this one, you can click at any of these options, or you can click here, and it's gonna take you to the same generalized, centralized settings area. And now we're gonna go through these emulation settings before jumping into pads or the network settings. Okay, so here we have our PPU decoder and our SPU decoder. We have two options, interpreter and recompiler. Recompiler is the fastest option, so just select that, because interpreter just translates the code line by line, while recompiler takes the whole code, translates it, and executes it, so it's much faster. But interpreter is way more useful to track bugs. So if you want to track bugs yourself in a game or in the emulator, you're always gonna select interpreter precise. So that way you can track bugs. But I don't think that anyone is gonna be tracking bugs, because it's a very time-consuming process. Here we have recompiler ASMJIT. This is the old recompiler, and it works with the low end of the spectrum. You can select this for a couple of your games, but this one has excellent implementation, so most of the times you're going to be using that. But if you get any runtime errors because of the games, you can just fall back on this recompiler. But I don't think that you're going to be using this one, because LLVM has excellent implementation nowadays. They really stepped up their game in the latest revisions. Okay, so next up in additional settings, we have enable thread scheduler. Whatever operating system you're using, especially Windows, it's going to have its own scheduling priority. So that means that Windows is going to tell the processor and the system how it should prioritize tasks. Which of the tasks is going to get most of the RAM, most of the CPU, most of the GPU, and stuff like that, something along those lines. Yeah. but we are gonna override that settings with our emulator settings, enable thread scheduler. So our emulator is gonna tell the resources that how they should be allocated. So definitely enable this option whether you're on a high end or low end or mid end. Lower SPU thread priority is particularly useful on low end of the spectrum. So if you have a low end PC, try enabling that, especially if you have 2 cores. So if you have a dual core old processor, try enabling that. But in my experience, it's a very experimental feature. I didn't get that much performance gain, so I just leave it disabled. But depending on the game and depending on the circumstances, you can try enabling that. So if you get better performance, then leave it enabled, otherwise leave it disabled as default. Enable SPU loop detection. This is a really useful feature, and you should always leave it enabled whether you're on a high end or low end, because it detects if there's a loop. So instead of just executing the same instruction over and over and over again, it can just detect that there's a loop coming, and then it can just run the loop and you can get potential performance. Yeah. SPU cache is like a CPU cache, where instead of just fetching the instructions over and over again, you can just fetch it from the cache because it's way faster. So enable that whether you're high end or low end, and it will ensure your stability and your performance. Accurate exfloat is a feature in RPCS3 where you can fix some bugs, but it's going to cost you a lot of your performance. Some of the bugs can be fixed by checking this option, but I must warn you that you're going to get 12 to 15 to 17 FPS or something like that. You're going to get amazing accuracy, but you're going to get like way less performance with this one. But it kind of fix bugs. So there were some games where I was stuck in some areas and game would just crash, or there were some horrendous bugs. So I just enabled this option, got through those areas at a low speed, low FPS, and then I disabled it. But you should leave it disabled, because I don't think that gaining accuracy is worth sacrificing as FPS. TSX instructions should always be enabled. So this is the instruction set, like for PS2 we have SSE, SSE2, SS3, SSE3, SSE 4.1, AVX, AVX2. So these are the CPU power tools that tells that lets CPU perform some very complicated calculations. So SPU block size, so it's the data block size. How big do you want it to be, mega or giga? If you have a big SSD or a big hard drive, it's worth trying giga or mega. In my experience, I didn't notice any performance gain, but it was actually counterintuitive, where I got some stuttering, so I don't recommend using it. Just leave it to safe. Again, it's an experimental feature, so try with your different games. Preferred SPU threads is auto, let it decide, so don't worry about that. In GPU section, we have renderer, and I'll select Vulkan, so it's going to be selected by default. Now remember, Vulkan is the fastest renderer, while OpenGL is the most accurate renderer. So we have selected here Vulkan, and in the latest revision, they've really implemented Vulkan compatibility in the emulator. So for most of your games, this option is going to work just fine. However, if you get some graphic error or slow speeds, you can always select OpenGL, which is more accurate. But if you want the best performance, select Vulkan. Now I must warn you that you're not going to have Vulkan option if you're using a low-end PC. So just keep that in mind, because on low-end PC it's not really supported. So you're only going to get disabled video output and OpenGL. So just keep that in mind, and you're just going to have to go with OpenGL. It's a relatively new machine. It's a 6th generation i7, not that high-end. It's actually a mid-end to low-end. But it does have Vulkan, so select Vulkan if you have. Here you can select the graphics device is selected, aspect ratio, frame limit, anti-scope refiltering, anti-aliasing. Default resolution is 720p. We can select 1080p, but this is the best implementation. Just leave it to that. Leave it to 720p. If you have a high-end PC, you can. And by high-end, I mean high-end graphics card, you can select Full HD, or if you want to go crazy, then just just use this slider and it will let you do the resolution scaling for yourself. Yeah, but in my experience 720p is the best, even if you have a low-end PC. Even then, if you drop back to 480p on a low-end PC, it's going to give you worse performance. So just select 720p. But again, if you want to experiment for different games, you can just always select 480 on a low-end PC and Full HD on a high-end PC. But this is the sweet spot, the best compatibility. And if you do choose to use this slider and choose your own crazy resolutions, you might get some weird artifacts or missing graphics, and then you can use this scale, resolution scale threshold, and it might solve some of those problems. In the latest revisions, I think it has a good implementation, but again, these are experimental. Legacy single-threaded in the shader mode, it's an old way of doing things. It's going to be really slow because it's only using single-threaded, but it has way better compatibility. But I don't think that we need to worry about that because most of the machines out there are multi-threaded and multi-cores. So we can just select async multi-threaded, and in the latest revisions, it has a really good implementation. Async with shader interpreter, as I mentioned before, interpreter is a really slow method of translating the computer code into assembly code and then running it. So do not enable any of these options because we're just going to keep it to that. Okay, so number of shader compiler threads, we're going to keep it to auto, let it decide. Write color buffers. So our color buffers contain our RGB and sRGB color data. So this data can be used for various purposes. So if you want to enable that, it's experimental. So just use it as on each of the games that you might have and that you want to get the best performance out of them. But don't use it as a global setting. In strict rendering mode, the second option, sometimes you can get an error because of the API. So for example, if you have a Vulkan error or OpenGL error, you're playing a game and then you get this error regarding an API, you can select this and it will bypass the API compliance. So it will basically let you run run the game even if you don't necessarily meet the criteria for the Vulkan render or the OpenGL render. VSync is the option where it's gonna let you prevent screen tearing effects. So, but it can take a toll on your performance, so don't enable that and never enable VSync. Stretch display area, if you don't want the black bars up, down, left, right, so just stretch it, you can do that. So in some of the games, there's a 3D option, so enable 3D view or enable 3D, you can use that, but I don't think it has that much practicality, and it's still the emulator is still in alpha phase, so I never enable that, but you can try if you want to. Disable vertex cache, it's never a good idea to disable the vertex cache. Never disable that because it's gonna let you store all of the GPU's most used data. So if you're just fetching the data from GPU over and over again, when you need to fetch data over and over again, you can store it in the vertex cache, and instead of fetching the data from GPU, you fetch it from vertex cache. Don't disable it unless you have a high-end GPU. So if you have RTX 3080 or something crazy like that, then you can disable it, because then it would make sense, because your graphics card is actually faster than the cache because of the newest GDDR6X memory. So multi-threaded RSX is also a very good option. It stands for Reality Synthesizer. Reality Synthesizer is the GPU for PlayStation 3, which was co-developed by NVIDIA and Sony. And if you have 4 or more cores, definitely enable this. It's worth a shot. So 4 or more cores, high-end PC, definitely enable this and try it with each of your games. I can't stress that enough, that the best thing that you can do with an emulator is try different settings together. Okay, so in audio section we have XA Audio 2, which is pretty self-explanatory. I'm not gonna explain all of that. Yeah, OpenGL is also another plugin, but I think X Audio 2 has the best implementation. If you want 5 to 7 FPS increase in some scenarios, in some specific scenarios, and you have a low end PC, just disable audio output. So if you disable audio output, in some cases, it can actually give you more FPS. So just throwing that out there if you have a really crappy PC, low end PC like mine. And audio channels down mix to stereo again has the best implementation. That's why it's selected by default, or you can use any of these profile. I think they have pretty good implementation as well. If you want all of the audio to be dumped into a file, you can select this option, or convert to 16-bit instead of 32-bit. Here you can select the microphone, but I don't have any microphone attached, any of the external microphone. I have the volume, enable buffering. I just disabled it, so that's why it's not letting me enable that. Yep, enable buffering, always enable buffering, because it's gonna let you process the sound. In I/O, if you have the joysticks or the steering wheels or the pedals or any camera or sensor, motion sensors, you can just select from here. But it's still in alpha phase, so I don't recommend that you do any of that. Just play with your keyboard or your controller. Again, you can try, up to you. In system, you have English keyboard, pretty standard stuff. Clear cache automatically. I never clear cache because then I'm gonna have really crappy compilation times, so never clear cache. Unless you want to install a newer firmware version, then you can clear cache. But if you're just sticking to the old firmware, that's fine. In network settings, we have network status, which is disconnected, PSN status. So simulator RPCS. RPCN actually lets you connect to a customized server if you want. But again, don't mess with these options because they haven't been implemented. They haven't been implemented yet. And in advanced, we have debug console mode. So remember when you wanted to tinker with your firmware, if you want to do that, just do debug console mode. So it will let you emulate that function. And here we have accurate LLVM DFMA, and I think it's, let me see, it's only compatible with OpenGL, I think. It's not enabling it for some reason, but it's actually just a flag for your compiler that it's going to give you better accuracy. It's already enabled. Accurate RSX reservation access. So if you've enabled this option, try stringing that option and this option together to get the best performance gain. But if you were getting low FPS, then just disable this one, because it's more for accuracy and not for performance. PPU LLVM accurate vector NANDs. I think this one works best if you yeah, it's gonna work best with the recompiler. So to string this setting, you're gonna have to select OpenGL, go to advanced, and then select it. So this is the best best combination of settings. But if you have Vulkan, then don't enable that. It's gonna give you more of an accurate emulation. So silence all logs. If you don't want anything to do with logs, you can use that. Sleep timers accuracy is pretty self-explanatory. Remember when your PS3 console just went to sleep and put the screensaver on. So I think it's emulating that. Sparse threads are unlimited. The firmware libraries are some of the specific options that you can enable to get the most out of your emulation. So if you want a specific function which is not available by default, so I can just select one of them and then get that option. But they're mostly for debugging purposes, because look at how many there are. So if you want to track down bugs, you can just use these libraries. Read and write depth buffers. It's worth trying. Read depth buffers and read color buffers. Again, these three are experimental features. Sometimes they can increase performance, but in Dark Souls, I think you get a black screen. But definitely try these options on each of your games if you want to get the best FPS. These contain RGB and sRGB data. So, and these are experimental features, so try that. Try stringing them together and see if it works. Disable on disk shader cache. Never check this option, because you're not going to get on disk shader, so you're going to have real-time shader compilation. So what's the purpose of disabling this? Because you're already going to have so many shader files on your disk, and you need to use that. So if you disable that, you're not going to use the on disk shader file that you've collected for God knows how long. Disable native float 16 support. This can actually give you a little bit less accurate performance, but sometimes in some of the games and some of the code, it can actually give you better performance but less accuracy. Okay, so relaxed Z equals sync. I think this is our last option in terms of performance. So Z culling is a technique where you do not render the unnecessary objects. For example, let's say I'm playing a game and there's a house nearby. Let's say I'm playing Red Dead Redemption 2 and there's a house or there's a bar, but there are also objects that are behind the bar. But I haven't gotten to that area yet, so it would be pointless to render those. Yeah, so we're not going to render it, and it's going to give us a little bit of performance. But if we have a high-end graphics card, then why won't we want the accuracy? Why won't we want the smoothness? So if you have a RTX 30 series graphics card, you can leave it enabled. And in Emulator, we have pretty much the standard stuff. We're going to leave it here. This is going to let you see the FPS on your top left corner or wherever you want. You can select it from here. And in GUI, you can use any of this, customize your UI. Yeah, so like that. Totally up to you. Pretty good, I would say. And then we have pads in here. If you want to attach a controller, you can do that through here. Xbox controller, DualShock, or any of the custom joysticks that you might have. You can adjust the sensitivity here. But if you select DualShock 3, it's going to let you adjust all of that good stuff. I don't have it connected, so that's why it's not letting me. Or you can make a whole new profile and choose a profile whenever you're playing a game. So custom controller. So it's a pretty standard stuff. And advanced, I think we already did that. We have RPCN. So if you want to connect to a customized network, you can do that through here. The host and then the username and password. And if you have set up a token system, you can put the token in here. Totally up to you. But again, it's in alpha phase, so it doesn't have the best implementation. So if you're planning to just play multiplayer, then I wouldn't recommend that. In trophies, we have Skylanders Portal. It's a game where you can use this portal for the game. Here you can adjust the make sure that your games are in a grid or they're in a list, and here you can zoom in, zoom out on your games. Then we have show debugger. We don't want anything to do with the debugger. I don't know how to debug this emulator. Game refresh, and then these are the pretty simple tools. Decrypt PSV binary. So some of the binaries that you might have might be encrypted. I had like a couple of encrypted binaries. I tried to decrypt them through this option. It didn't really let me. Always gave me an error, but you might have better luck than me. Okay. So there we have it, guys. That's our complete look into RPCS3. Hopefully I covered all of these options in detail. Now I'm gonna do the low-end settings. So if you have a low-end PC, follow these instructions. Recompiler, yep. Experimental, so try enabling, disabling that. Enable safe auto. GPU Vulkan. Perfect, default, async. Perfect, same. These are also experimental, so make sure that you try it first. And for high end, I always do these settings. Okay, so that brings us to the end of the tutorial. Hopefully I've covered everything, and hopefully this video was helpful to you guys. Hey guys, hope you're all doing okay. This is Rokat and welcome to the complete tutorial Vita 3K. In this video you will find everything that you need to know, like how to set up the emulator and what do all the options mean. I'm gonna put timestamps in the description. These are the minimum specifications and these are the recommended specifications. So without further ado, let's get started. PS Vita came out in 2011 as a successor of PSP alongside backwards compatibility. It was well received at first, but a lot of critics argued that it might be too expensive, especially considering the dawn of smartphones. It featured a Cortex A9 MP quad-core processor and PowerVR GPU alongside 512MB of RAM and 128MB of VRAM. It was the high-end spectrum of the time. Very unusual choice of architecture, but it made sense regarding portability. But considering the architectural limits, it would not be emulated for a long time. Vita 3K first appeared in 2018, almost 7 years after the release of the console, which is pretty usual. 3 years of constant development, bug fixing and redesigning. It can play about 13 games out of 487, which is not a lot, 39 games which are relatively stable and can go in-game without a whole lot of reliability, and about 58 games that go in-game but are not stable at all. All others are a work in progress, meaning they either get stuck on the menu or won't pass the boot screen. So before you play a game, I strongly recommend that you look it up in the compatibility section of the Vita 3K website. It will list the issues associated on GitHub, and then you can adjust your emulator settings according to those issues. As time progresses, this emulator will develop and hopefully we will be able to boot titles without any issues. So to download this emulator, and it's pretty easy. We just have to go to vita3k.org. So I'm just gonna open up the browser and just gonna go to that website. vita3k.org. And this is an experimental PS Vita emulator, and here we have all the tabs. And if you want to support these guys on Patreon, I would highly recommend that, especially if you're a big PS Vita fan. So we can just download it from here, and as you can see, it's available on Windows, Mac OS nightly. So I don't know what you're doing with your life if you're not running it on Windows, because the issues associated with Mac OS, Unix and Linux, they're just insane. And if you go into the compatibility section, it will list all the games that are compatible, which is not a whole lot, but it's there. So we can download it from here, but I've already downloaded it, so I don't need to do it again. Now before we begin, I should mention that you should have C++ redistributables AIO 2010 to 2019, x86 and x64 installed, plus DX web setup. So now let's launch it. So this is our downloaded file, and I'm just gonna extract it right here. Okay, so I'm just gonna launch it now, and this is our log. That's gonna tell you everything that you need to know and every event that happens with your emulator. And this is a welcome message. You can just say show next time or close it, up to you. Now we have to create a user. I've already created a user, so I'm just gonna use like user 1 2. Okay, and just gonna put user 1 2, and then here we have our content manager, trophy collection, and settings, filter, title ID, version, category title, which are pretty self-explanatory. So if we go here, this is our file dialog box, and open preference path. You can open your preferred path if you want. Then we have install firmware, install.pkg, which is a package file, install.zip or .vpk, which is a Vita extension, or install a license regarding a specific software or a game. And in emulation, we have last apps used. I haven't used any apps, so it's empty. So this is a recently used section. In debug, we have a lot of different options, which we're not gonna go into for obvious reasons. And in configuration, we have settings, which we're gonna go into in just a minute. User management, you can manage your different users. For example, I have 2 different users, users 1 and users 1 2. And in controls, we have keyboard controls. All of your controls are here. You can map any buttons. I won't recommend playing it with a controller because it can be a little bit finicky, but you can try and experiment. And in help, we have about and welcome section. Okay, so in terms of UI, there's not a whole lot, and this emulator is in its pretty early development stages. So I'm not expecting a whole ton from this emulator. If you go into settings, here's our settings, and in core you have to install the firmware first, and it will show you a message that's gonna say that no firmware has installed. So it will give you a link that you can click to go to download the firmware, but just for the sake of this video, if you want to install firmware, you can do it from here. And in compressed, I have this file that I've downloaded, and you can download this from a PS Vita official website. If you just write PS Vita firmware download, and then you can install it. Some games are gonna require this firmware to be enabled and running on this emulator, while you can run other lightweight titles without any firmware. So this is our core section, and we're just gonna go with automatic. If you know what you're doing, you can also select manual and enable all these modules or specific ones. Now, how would you know which module to enable and which one to disable? You can search the game that you want to play and see what problems is that specific game is suffering from, and then you can select these modules. But for sake of simplicity and performance, we're just gonna go with automatic, and it's in alpha stages, so it's not gonna do a whole lot. And then this is an experimental options, which is just gonna use the library kernel and drivers, and you can enable that. This is only gonna work with specific CPU extensions. For example, if you have SSE3, SSE4 or AVX, then it can sometimes give you a little bit of accuracy. But as it's stated right here, it's experimental, so you would always want to experiment with this first. And in CPU section, we have two CPU backends. One is Unicorn and the other one is Dynamic. PSVITA runs ARM architecture, and the best backend theoretically is Unicorn. It still has a lot of execution and implementation to go, but it's very promising. Both of these options are experimental because of the development stage of the emulator. Unicorn does support JIT compiler, just-in-time compiler, a little better, but to make it short, if you have a new architecture and new hardware, you would go with Unicorn. Dynamic will do just fine with older CPU models because of the CPU extensions. Unicorn engine does have a lot of untapped potential, especially with Vita 3K, and we're only going to see improvements. If you get a runtime error or a crash, try changing it to Dynamic. Dynamic is an ARM recompiler, so first you would try Unicorn and then fall back on Dynamic. Hopefully that explanation helps. But these optimizations are only going to be enabled with Dynamic. With Unicorn, these are automatically enabled and are integrated into the backend itself. And in GPU, we have the SPIRV shader. Again, also an experimental options. It can work with some GPU and CPU extension, so feel free to try it with this one. In systems, we have circle or cross, which button do you want to use as your main button, and emulator console. It's gonna try to emulate the UI of PlayStation Vita. And in emulator, we have a bunch of more options. These are not really performance oriented. This AT9 audio decoder can help in some games. So if your game supports the AT9 audio decoder, you would might want to disable it if it suffers from audio starvation problems. Again, this is another experimental options. And in GUI, we have different user interface settings, and in debug we have these. So again, there's not a whole lot to go on. This is pretty much it, and you can run any game that you want, given that it's supported, of course. So there you have it, guys. That was a brief summary of the emulator, and it's not a whole lot because it's still in its early stages. I've heard that the developers don't get enough time to develop this emulator. They've been trying since 2018 and they've come really far, but it still has a long way to go. So anyways, I hope you guys enjoyed this video. Thank you so much for watching. Catch you guys. Hey everyone, hope you're all doing okay. Welcome to the complete guide to PSP Emulator, the PlayStation portable emulator. This is going to be a detailed guide and it's going to be very in-depth, so I'm going to put timestamps in the description. I do, however, encourage you to watch the entire guide to get the complete understanding and every single nuance of this emulator. To give you some context, these are the minimum specifications for the emulator. Anything above that is mid-end. Did you know that this minimum specification is not actually minimum? Yeah, you can run games with 60 FPS with playable resolution on a PC that is much lower end than this. Okay, so without further ado, let's get started. And did you know that PSP is not the first PSP emulator? Yes, there is this emulator called JPCSP that was introduced way back in July 2008, while PSP was introduced in late 2012. I remember running JPCSP and boy, it was absolutely awful. I ran it in 2011. Even if you had a high-end PC back then, you couldn't even get playable FPS. The major reason was because it was written in Java. This language, first of all, requires a totally different isolated environment to run in, and it is not that powerful for emulation. If you want to emulate NES, SNES, or something along those lines, it is worth it. But heavier projects have a lot of strings and modules associated with them. PPSSPP came and it absolutely shocked me to see the performance comparison between the two emulators. Even in its early development stages, it was amazing and gave playable FPS for most titles. There is a lot of hard work that went into it, but the major reason is because it was written in C. It runs natively on the machine without the need of an external environment. Since then, the emulator has come a long way, and honestly, you can run this emulator just fine with the default options. There aren't a lot of emulators that I can say this about, but there are so many options that let you run this emulator and upscale it if you have a really high-end PC, and also lets you downscale if you have a PC from the 2000s. If that wasn't enough, they have builds for iOS, macOS, Android, Linux, BlackBerry, Nintendo Switch, and even Symbian. Do you realize how overkill that is? You know Symbian, the Nokia operating system for mobile back in the good old days? At this point, the developers are just flexing on us. So to get started, we're just gonna download it. As all of my guides, I highly recommend installing DirectX, Web Setup, and Visual C++ redistributables from 2010 to 2019, both x86 and x64, because they can get rid of most of the errors. There are two ways of downloading this emulator. First is the official stable release, and the other one is nightly builds. We're gonna go with the stable release because there is no benefit of running the nightly build in this specific scenario. So let's download it. We're just going to write ppspp download, and then this is the first website that you go to. So look at all this: Windows, iOS, Switch, BlackBerry, Migo, Symbian, Pandora, Linux. Oh my god. So you can download the zip file, and I actually recommend downloading the zip file because everything is pre-installed and you just have to extract it. I've already downloaded it, so I'm not going to download it again. And I have the folder open here, so we're just going to launch the 64 version, and let's go to full screen, or even this is fine. Now there are two versions of this release: Windows 32-bit and 64-bit. If your PC supports a 64-bit platform, please run it, otherwise you might not get the optimal performance. Before I get into the options, I should mention that I'm gonna divide the options into 4 categories. One's for higher end PCs, one's for lower end PCs, ones that should always be turned on or off regardless of the specifications, and the ones that are experimental. So let's get to the UI. In our UI, we have load, open directory, open from MS PSP game, so that's a specific directory. Open memory stick, if you want to open up the virtual memory stick, open new instance. So if you have 2 games running at once, so you can actually open a new instance. It will open a brand new PPSSPP window, and you can actually play something else on here. So that's pretty cool. I haven't seen a lot of emulators do this. We have save state slot if you want to save your game, load state file, save state file if you want to record or exit. In emulation, we have pause, stop, reset, switch to UMD, the PSP source media, and if you want to display the rotation, then that's totally up to you. These are all debug options, or disassembly and GE debugger, and we're not going to get into that. But if you are a developer and you want to debug stuff, that's up to you. Then we have game settings. I'm going to go into that a little bit later. So first I want to cover the UI. And then in help, we have all these different things. If you want to buy gold as a way to support the developers, I recommend doing that actually. In recents, it's just going to show our recent files. And then homebrew and demos, if you want to run just like a demo or like experimental ISO, you can run it from here. This is our grid view, and this is our list view. And then our settings, this is home. This will actually enable us to go full screen. So actually, let's go full screen. Yeah, that's better. I don't know why this pops up. It's so annoying. Load, credits, all of that is pretty self-explanatory so far. So let's get into the settings, the meat and potatoes of this tutorial. So first up is graphics, and there are a lot of options to go through, and I'm gonna try my best to explain them as much as I can. First up, we have backend. In backend, we have OpenGL, Direct3D 9, Direct3D 11, and Vulkan. For mid-end to high-end PCs, I would always recommend using Direct3D 11. please always use this. I think low-end PC means something different to everyone, because I remember an era where low-end PC meant a really low-end PC, and we're talking megahertz of speed in terms of the processor speed. It wasn't even gigahertz. So please always try to run Direct 3D 11, but again, if you have a low-end PC and you're not getting playable performance, run Direct 3D 9. OpenGL is only for accuracy, and I don't recommend running it because only if you have a high-end PC and you want the utmost accuracy, not the smoothness. So that's up to you. You can run OpenGL. And Vulkan is also for high-end PC. So if your PC actually supports Vulkan, you can use that. But again, I would recommend Direct 3D 11. The reason is this implementation have had so many iterations and revisions that they have managed to work out all the possible bugs. But Vulkan is new to this emulator, relatively new. So that's why we will always use Direct 3D 11, even on a high-end PC. So that's what I recommend. But Vulkan does have its advantages. So if you're running an open world game and your PC is not that high-end and you don't want to deal with shaders and compilation of shaders, you can actually choose Vulkan. But again, 3D 11 is the best option. Then we have our device. It's selected my GDX 960M. I'm on a laptop, so it's a pretty low-end card. So it's already selected that, but if you have multiple cards, you can select it from here. Microsoft Basic Renderer Driver is just for debugging purposes, because in most cases it gives you null output. So that's why we never use this. So we're only going to use these two. So either your dedicated graphics card or your onboard chip. So if you have a dedicated graphics card, you can actually select that from here. But if you're on a low-end PC and you only have an onboard GPU, you can select that one. Then we have mode. So it's buffer rendering and skip non-buffer faster. I remember there used to be 4 options in here, but they removed the extra 2 because I think most of the stuff is pretty much behind the scene and implemented in the emulator itself. So our buffer rendering is actually a technique where you actually see the contents of the game, what's going to happen, and it's actually going to make an informed prediction. It's going to load the contents and then it's going to run. So it gives you a lot of smoothness and accuracy as well. That's why we always select buffered rendering. And skip buffer effects is you do not do buffering in this scenario. So if you have a low-end PC, you would select that, but we always select buffer rendering. And again, this has so many iterations and revisions that this is the option to go with. But if you have a really low-end PC, select skip buffer effect, so it's not gonna buffer, it's just gonna run straight away, which can feel a little bit irregular because the playing patterns can differ. Then we have mode simulate block transfer effects. It's just the simulation of the animation, so that's why it's selected. You can disable it on a low-end PC, but it doesn't take that much of a performance toll, so I recommend keeping it enabled. Then we have software rendering. So let's say you have a Surface, a Microsoft Surface Pro, and you don't have a high-end dedicated graphics card. You don't even have a high-end onboard graphics chip. In that case, you would select software rendering. Or let's say you're running on a safe mode. I don't know, like this scenario doesn't even apply to anyone, I think. But let's just imagine you're running on a safe mode and your graphic card is actually disabled, and then you would select software rendering if you really want to run your game, and it will actually render the game using the software instead of using the hardware of your graphics card. So I think it's for experimental purposes. But if you don't have the onboard GPU and the dedicated GPU, this is your best option. And I think if you have a capable processor and RAM, it can actually give you playable FPS and also very good resolution. Okay, then we have frame rate control. First up, we have frame skipping, and here you can actually select the number of frames that you want to skip. It goes up to 8. I don't know why it goes up to 8. It should go up to a little bit more, but I think if you go higher than 8, then you're not gonna get a playable experience. It's gonna skip way too many frames to know what's going on the screen. And then we have frame skipping type. Number of frames or percent of FPS. It's totally up to you if you want to skip a number of frames. So for example, let's say it draws 60 frames per second and you want to skip 7 of them. So it can actually give you a playable performance. But if you want to skip a percent of FPS, so let's say 60 FPS and I want to skip 20% of that, you can also select that. Auto frame skip is an option where it just detects your game and your specifications and it skips accordingly. So let's say you have a high-end PC and you have this enabled. It won't actually skip any frame, only maybe in some loading zones, but it will actually look at your game and your specifications and decide whether the frame skipping is necessary or not. Then we have alternative speed. So if you want some game running at 200% or 300%, let's say you're running through credits, you just ended the game, you're running through credits, that's when you would use, and you can't skip it for some reason, then you would use 300%. Then you have alternative speed 2, and then it's disabled. They don't really have use case in my opinion. Then we have our post-processing shader number 1. So if you want to customize the actual graphics, you want to apply a filter, then you would actually use this one. So they have a bunch of shaders here. I would say that FXAA anti-aliasing is pretty good. So you can actually use that one. But I always keep it off because this unnecessary calculation, unnecessary workload, and the games look just fine without it. So you have CRT scale lines. If you want that monitor effect, you can do that with grayscale, bloom, sharpen, and then we have a bunch of other post-processing shader. PSP color is a particular one where it would just use like PSP color. It would try to emulate that, but I recommend keeping it off. You can actually enable more than one post-processing shaders, but again, it's just unnecessary load on your computer, and I won't recommend it even if you have a high-end PC. We have full screen, yep, and display layout editor. It says auto scaling. I will leave it to auto scaling. You can actually use it as a portrait if you want. Rendering resolution is auto. So I would recommend using 2x PSP or 3x PSP. So they are pretty self-explanatory. At 2x, I'm just gonna run 2 times the resolution of a PSP. So if your PC actually supports it, you can actually use one of these options. Up to you. So let's select 2x PSP. It's a sweet spot where you're not actually taxing all of the resources of your computer, and it would also give you a pretty nice resolution to play with. VSync is if you have your screen tearing effects on your screen for some reason, you can enable it, but I always keep it disabled. It's unnecessary workload. Render duplicate frames to 60 Hz is actually disabled, and I think that if I enable it to Vulkan or OpenGL, it will actually let me enable that, but we're gonna go into that later. Hardware transform is enabled, and it's actually a very good speed up option, and you should always have it enabled. So it actually tries to transform your hardware. So as you know, PSP has pretty low specifications, but if you can emulate natively, that's fine, but you can also use the full resources of your hardware. So that's why we have this option right here, and you should keep it enabled. And then we have software skinning as also a pretty good option, and it can give you a little bit of speed up, but if you're on a high-end PC, you might want to disable that. So it's actually experimental, and with some games it can cause a little bit of hindrances, so just use it occasionally. depending on your game. And then we have vertex cache. Vertex cache can actually give you performance boost. So if you're on a low-end PC, definitely always enable that. It says may cause temporary flicker, but with the majority of the games, it's not the case. It's just fine. So you would enable vertex cache if you want speed up. But on high-end PCs, your graphics card has actually got a cache of itself. So in that case, it would be pointless to use vertex cache when your graphics card cache is actually faster. Clear frame buffers on first use. So for some reason, if you're not running your game correctly and you're getting some runtime errors, you can actually use this one. So it's going to clear frame buffers on the first use. This is going to clear all that data. And if you want to, if you're debugging this emulator, I think for a specific title, you would enable that, but keep it disabled for the most part. Lazy texture caching, again, this is a technique where the texture caching is not preferred, and it can actually reduce the calculation, reduce the load, and give you a little bit of speed up. But it can also take a toll on your accuracy. So I would say that keep it disabled, but if you have a really low-end PC, enable it. Retain change textures, again, it's pretty similar to the option to this one, but it can give you a performance boost. In majority of the games, just keep it disabled, but in some experimental games, so you know, in PPSSPP website, they have a compatibility list, and the ones that are in game, and there are only a number of games, you can actually try enabling that, so it might solve some of the bugs. So it's an experimental feature. Disable slower effects, again, pretty self-explanatory. It's going to give you speed up, but if you want the accuracy, don't enable it. Spline, Bezier curves, quality. So all of the shapes, the curves, quality, how do you want it to be? You can select it low, medium, high, and the workload actually increases as you go high. So I think high is a pretty sweet spot. So if you have a mid-end to high-end PC, select it high. It doesn't take that much of a toll on your performance, but if you're a low-end PC, just keep it to low or medium. You would keep it to medium if you're a low-end PC, but if you're a really, really low-end PC, just keep it to low. Hardware tessellation, these are your rectangles, your triangles, your rectangles. And you would enable that. So this is going to give you a really, I think, accurate experience, but it also takes a lot of toll on your performance. Only enable it if you have a high-end PC. Then we have our texture scaling. Upscale level is off. So I just want to take a moment to talk about upscaling level and the resolution. So we're rendering it at 2x PSP, but it's just going to render it at 2x PSP. So let's say the PSP resolution, for example, is 480p. So it's just going to render 2 times 480p. But upscaling is just enhancing a little bit more to give you that extra resolution and extra crispiness in your graphics. So upscaling level should be selected to 2x or 3x. I can select it to 5x on this PC. I can actually select it to 5x, but at that point the games look so artificial. They just lose the naturalness to them. So that's why I always use it to 2x or 3x, because 5x is just way too much upscaling to a point where you can't even recognize the game anymore. So yeah, upscaling type is XBR, XBRZ, and we have hybrid. Then we have hybrid plus bicubic. If you select this one, it's gonna take a toll on your performance. It's gonna increase your workload. So I would suggest XBRZ. Again, this has had the most amount of revisions and bug implementations done to it. So that's why you would select XBRZ. These are two different techniques, but this is the most appropriate one, regardless of the specifications. And then we have deposterize. This is also an upscaling method, but this is an experimental option, so you would only use it for experiments. Then we have texture shader. It is off. I'm actually going to go into that later. So the options that are disabled, I'm going to go into that later. Anti-scoppering filtering is 16x. I would suggest 4x or 8x. 16x is way too much. That's why some of the time the graphics can look so artificial. When you have 2x PSP, then you have upscaler, then you have anti-scope refiltering. So because it wasn't 3D, like in spirit, it wasn't 3D. The graphics weren't amazing. The games were made for a 4-inch screen on a PSP. That's why these options, in my opinion, are overkill. That's why you would want to keep it to a minimum, even on a high-end PC. So that's just my opinion, and that's something that I've learned running this emulator and running various titles. Then we have texture filtering. I would also always select auto. So let it decide, or you can select nearest or linear depending on your preferences, but I would suggest auto. Let it decide on the title base. Then we have screen scaling filter, which is linear, again the same thing as this one. So if you have this auto select, you don't need to worry about this option. Then we have our camera device, integrated webcam, low resolution, for effects. So if you don't want the low resolution like entirely in your game, just on the effects, then you can turn this on. And it reminds me of the PlayStation 2 emulator, because they have the safe, balanced, and aggressive. So how much do you want it to be? Like how low resolution? Aggressive is just if you have a really low-end PC, but it's kind of counterintuitive because this is going to increase your workload as well. So if you have a low-end PC, you're better off just selecting safe or off. Now we have overlay information, show FPS counter, and show debug statistics. These are, if you want the information to be displayed up here, then you would select that. Now let's go through Vulkan. And a lot of options are going to get enabled now, because a lot of options are actually specific to Vulkan. So now we have texture shader, and these are two techniques, 4xBRZ and MMPX. MMPX haven't had that many revisions to it, so you can actually select the texture shader. But as I mentioned earlier, Vulkan is relatively new, so it might not give you the playable performance. It's going to give you a lot of accuracy, but maybe it can take a toll on your FPS. To be honest with you, I haven't tested it, but that's my prediction. So that's how it's now enabled. And this one is still not enabled. I think this is supposed to be the OpenGL render. No, still not enabled. Or we might have to run a game or something that might enable it. So I think if you have a higher refresh rate than 60 Hz, then it can actually help in that scenario. I would say that it's an experimental feature. Let's go to audio. We have enable sounds, sure, global volume, then alternate speed volume, and then audio backend restart required. It says D sound is just selected to auto. It doesn't make that much difference, and this section is actually not relevant to performance. Again, as all of my emulator guides, I would suggest disabling the sound if you have a PC from the 90s. It can give you 2 to 3 FPS increase in some cases. Then we have controls, and actually these emulator controls are just way too good. They're amazing, and look at all these options. You can actually do control mapping, so for all of your buttons. And here we have the function keys. So if you want to assign something to these, you can. So a lot of options there. It's actually kind of overwhelming as well. So it says ignore game pads when not focused. So if you have minimized the windows, then they're not going to be on focus. If you have an on-screen touch, if you want to play, let's say you're on Android, you only have the on-screen, then you can use that. Then we have dead zone radius. So let's say you accidentally press something, or you accidentally touch something, then you can actually specify what should your dead zone radius be, so you won't accidentally trigger something. Then we have analog mapper mode. So if you want to map some specific keys to some specific options, that's your go-to right there. And then we have keyboard control settings. And then we have mouse settings. So you can actually use your mouse if you want. Well, that's good. In some cases, in some titles, it can come pretty handy. Then we have networking. So visit ad hoc multiplayer forum if you want to visit the forum. So enable networking VLAN, and this one actually only works in like very controlled scenarios. So I don't recommend using the networking feature because it's still in beta. And I tried using it on Tekken, but I was waiting in the lobby forever and no one came. So I think that might be the emulator itself, not the game. Then we have our MAC address in here. And then we have ad hoc server and chat, and then miscellaneous if you want to mess around with these options. But again, I would recommend not enabling this. In tools, we have the save data manager. If you want to mess around with your save files, load files, then we have system information, developer tools. In developer tools, we have CPU core. So if you want to run it on interpreter and you want to debug something, you can actually select it from here. And then all these debugging options. Remote disk streaming. This is another experimental option. I don't recommend using it. So it's going to stream a disk ISO or a CSO on a network, not on your disk. Then we have system settings, the language, the UI sound. So remember the sound that PSP plays. If you want to play that exact same sound. Enable compatibility server reports. I never enable it. So if you want to send feedback about some of your performance issues, you can actually enable that. Fast memory, unstable. So these are the actual emulation options, and these can help with your performance. Fast memory, always keep it enabled, whether you're on a high-end or a low-end PC. I know it does say unstable, but again, so many iterations and revisions have happened that this is actually very stable, and it's a very good speed-up option without losing any of the accuracy, smoothness, or FPS. Then we have ignore bad memory accesses. So let's say you get an error, runtime error, so you might want to ignore that for some reason. That's why it's enabled. But in some of the titles, it can actually get really bad, so I would always suggest to keep it enabled. Then we have input output on thread experimental. Again, leave it enabled because alongside your CPU core is also going to use threads. IO timing method is fast, lag on low storage. So I would suggest just keep it to fast. Yeah. Then force real clock sync. I don't recommend using this option, only in a few titles, so this is a pretty experimental options. Then change emulator PSP CPU clock. These are all the options that we have, and these aren't really that performance oriented. Then we have general check PSP for new versions. If you want to update them, set UI background. If you want to set it to a specific thing, that's up to you. Check full ISO in RAM. Cache full ISO in RAM. I actually misread that. I have 16 gigs of RAM, and if I have a 1 gig of ISO, I can actually fully cache that in RAM, and it's gonna run faster than it would have run on the hard drive or the SSD. Then we have enable cheats, PSP model. Which one do you want to emulate? 1000, never select that because there's no point. We go 2000, 3000, and then we have all these other options for your specifications, and I think that's it. We've gone through all these options. Again, some of them are the experimental options, and you should only enable it when you've tried everything else, and the other ones should always be enabled or should always be disabled. Now that we're done with the options, I'm gonna tell you this recommended settings for low-end PCs. So you will go into settings, and I'm talking about a really low-end PC, then you would use 3D9. So we're using 3D9, and we're also using buffer, non-buffer rendering. Again, I want to iterate, this is for a really low-end PC. Simulate, then frame skipping is set to auto. Post-processing shader is off, then full screen is on. Rendering resolution is 1x PSP. We want to put as like really low, just minimum load as possible, as minimum as possible, as less load as possible. Hardware transfer, you would enable it, but software skinning you would disable. Vertex cache you would enable, lazy texture caching, and then disable lower speed up. And then in here you would select low. Upscaling level you would turn off. And XBRZ, deposterize, you wouldn't enable it. And then anti-scope ring all the way to off. Camera device, I don't think you can do any of that. And in system you would enable fast memory unstable. And there you have it. These are your options for your low end. Now let's talk about high end, mid end to high end PCs. 3D11. We have 3D11, buffer rendering, yep. Simulate transfer effects, yeah. Auto frame skip is off. Frame skipping is off. Full screen 3x. We don't want VSync. We have hardware transform. Vertex cache will disable. Lazy texture caching we will put high, and hardware tessellation. Upscale level is 3x. XBRZ. And there you have it, guys. That was your complete guide to PPSSPP. It's a really impressive emulator, and I just can't get over the fact how many platforms it's available on. So I hope you found this guide useful. I hope you enjoyed this video. Thank you so much for watching. Catch you guys later.